In this video, we are going to be focused on solving the gambler's rule problem that asks us to find the probability of the independent event. Let's begin with the problem. We have two gamblers, A and B, bet on the outcome of successive flips of a coin. On each flip, if the coins come to pass, A collects 1 unit from B, whereas if it comes up tails, A pays 1 unit to B. They continue to do this until one of them runs out of money. If it is assumed that the successive flips of the coins are independent and each flip results in a head with probability P. So, what is the probability that A ends up with all the money? If we start with I units and B start with N minus I units. On the first bet, we will either win or lose the bet. If we win this first bet, the probability he wins the whole game now is when he loses the first bet, then the probability he wins the whole game now is. So, what's at the inside here? We can see that the process continues until either A or B win the game, which can be described as the diagram as follows. Let's denote the events as follows. E is the event that A wins the game. H is the point land ahead, and A win the bet. Pi equal Pe is probability that A win the big game when he has I coins. Let's use the conditional probability to check what will happen. The probability of A winning the game when he has the I coin is equal to the probability he win the game and he win the first bet plus the probability he win the game but lose the first bet. Apply the conditional probability formula and transform it. We'll get the equation. Denote Q equal 1 minus P. We have Now we have the relation between Pi minus 1, Pi and Pi plus 1. What shall we do now? We see that in this problem, P0 equal 0, A has already lost the game, and Pm equal 1, A has already won the game. So, what does it mean to our calculations?
Let's apply asterisk to the specific case I equal to 1. We have P1 minus P0 equal to P1 minus 0 equal to P1. Similarly, we have the following equation for 2, 3, I, and up to n. Sum of the first I equations, we will get Pi minus P1 equal to Q by P plus Q by P to 2 plus all the way up to Q by P to I minus 1 times P1.
The term gambler's rule is originally a statistics concept, most usually described as the fact that a gambler playing a negative expectation value game will eventually go broken regardless of their betting system. The earliest known version of the gambler rule is also known as the problem duration of the play, proposed by Pierre de Fermat in a letter to Christian Huygens in 1657. In which A and B have 12 coins each and they are bidding on 3 dice, whereas A gives a coin to B whenever a number 11 is rolled, and vice versa whenever a number 14 is rolled. So it's just a gambler rules problem with B, I, N.